a 2 GB log file upload caused connection reset by peer after 30 seconds and OOM-killed the container every 10 minutes. The root cause? The service buffered the entire request body. Here's exactly why. But first, let's cover the basics of designing a Pastebin that won't fall over. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Design Pastebin. A Pastebin is like a public bulletin board. You pin a note, get a ticket stub with a unique number, and the board automatically tears down old notes. The core challenge is simple. Accept text, store it, return a short URL, and delete it after a TTL. But the devil is in the details. The textbook design uses a single SQL database with auto-increment IDs and text columns. This works for 100 users but fails at scale. Auto-increment locks the sequence, text columns bloat the table, and without caching, every read hits the database. The fix: separate metadata from content, use a distributed ID generator, and cache aggressively. Store metadata like short URL, user, expiry, and a fast database. Store the actual paste content in blob storage like simple storage service, keyed by its SHA-256 hash. This keeps the database lean and allows content deduplication. Generate short URLs using base62 encoding of a random 64-bit ID. Here's the schema. The metadata table stores the short URL as primary key, along with user, content hash, and expiry. We create an index on expire_set for efficient cleanup. Content goes to simple storage service with a lifecycle policy. IDs are generated using a snowflake-like scheme: 41 bits timestamp, 10 bits worker ID, 12-bit sequence, then base62 encoded to a 7-character string. Deduplication saves storage. Normalize the content by trimming whitespace and unifying line endings, then hash with SHA-256. Use the hash as the simple storage service key. If the object already exists, reuse it. But always return a unique short URL per paste to preserve per paste identity. First, normalize the content, then hash it. Check if the simple storage service object exists. If not, upload. Generate a unique short URL and store metadata. This way, duplicate content shares the same simple storage service object, but each paste has its own short URL. Expiry is easy to get wrong. Use database-level TTL if supported, and simple storage service lifecycle policies for content. But never delete content before metadata. A read between the two deletes gets a 404. Implement soft deletes with a grace period. For DynamoDB, set the TTL attribute and DynamoDB handles deletion. For SQL, run a scheduled job. Simple storage service lifecycle deletes objects after 30 days. To avoid 404s, soft delete metadata first, then delete content after a grace period. Pastebin is a prime target for abuse. Use a Redis-backed sliding window counter. Set limits: 10 pastes per minute for anonymous users, 100 per minute for authenticated. Return 429 too many requests with a retry after header. This function implements a sliding window rate limiter using Redis sorted sets. It removes old entries, counts current ones, and if under the limit, adds the current request. The key auto-expires for cleanup. Pastebin is read-heavy. Cache metadata in Redis with a 5-minute TTL. Serve content via a content delivery network with simple storage service as origin, caching for 24 hours. On cache miss, fetch from DB and populate cache. Use short TTLs instead of expensive cache invalidation. First, check Redis. If found, return it. If not, fetch from the database and populate the cache with a 5-minute TTL. This reduces database load significantly. At massive scale, shard the database. Use consistent hashing on the short URL to distribute writes and reads across shards. Embed the shard ID in the URL prefix for direct routing. Virtual nodes ensure even load distribution. Create a consistent hash ring with virtual nodes. For each short URL, determine the shard and route the request accordingly. This minimizes data movement when adding or removing shards. This is the same issue we highlighted at the start. Here's exactly why that happened. The paste service was loading the entire request body into a buffer before writing to disk. A user uploaded a 2 GB log file, which blew past the 4 GB container memory limit. The OOM-killer terminated the container, and the load balancer retried on another container, cascading the failure. The fix switched to streaming uploads. Pipe the request directly to disk or simple storage service without buffering. Set a maximum request body size, e.g. 10 MB, and reject larger payloads with a 413 status. Add a memory limit per request using a streaming counter. This prevents OOM kills and cascading failures. This code concatenates all chunks into a single string, buffering the entire body in memory. For large uploads, this can exceed the container's memory limit and cause OOM kills. Always stream the request body to disk or simple storage service. Never use auto-increment for a public Pastebin. Attackers can enumerate all pastes by incrementing the ID. Use random base 62 strings instead. A single trailing space changes the hash, causing duplicate storage. Always normalize content before hashing. If you delete the simple storage service object before the metadata row, a read that arrives between the two deletes gets a 404. Always delete metadata first, then content. The article uses crypto create hash SHA-256, which is Node.js built-in. In newer Node.js versions greater or equal 15, the crypto module's create hash is synchronous and safe, but the digest hex call is also synchronous. Ensure you are not accidentally blocking the event loop in a high-throughput server. Consider using crypto-subtle digest in a worker thread for very large pastes. The article warns against buffering the entire request body, but doesn't show how to stream directly to simple storage service. Here's a Node.js example using the Amazon Web Services software development kit. Upload with a readable stream from the request, avoiding memory issues for large pastes. The article mentions compressing content before storage, but doesn't warn about the cost of decompression on every read. For high-read services, consider storing both compressed and uncompressed versions, or use simple storage services automatic decompression with content encoding. gzip only if clients support it. Also, compression ratios for text are high, but CPU cost for decompression can add up at scale. When things go wrong, use these commands. For upload failures, check the request body size. For missing pastes, verify simple storage service object existence. For rate-limiting issues, inspect RIDI's keys. For database latency, use CloudWatch metrics. Let's run through some common interview questions. How handle duplicate content under concurrent uploads? Use content-addressable storage with distributed lock or conditional write. When choose DynamoDB over PostgreSQL, DynamoDB for automatic scaling and TTL, PostgreSQL for complex queries and strong consistency. What happens when RIDI's cache goes down? Fall back to database with circuit breaker. Use local in-memory cache as second layer. How generate unique short URLs? 64-bit Snowflake ID base 62 encoded to 7 chars. Ensure randomness to prevent enumeration. And a few frequently asked questions. How generate short URLs? Base 62 encode a random 64-bit Snowflake ID. SQL versus NoSQL for Pastebin. NoSQL DynamoDB scales better. SQL for strong consistency. How expire pastes? Database TTL plus simple storage service lifecycle. Delete metadata first. How deduplicate? Normalize content. Hash with SHA-256. Reuse simple storage service key. To recap, stream uploads to avoid OOM, separate metadata from content, normalize before hashing for deduplication, use random short URLs, cache with short TTLs, and always rate limit. These patterns will keep your Pastebin running smoothly at scale. Ready to go deeper? Up next, design TikTok, then design Reddit, then design Tinder. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.